All right, so let's move on to example 3, our third final example. It says the medians drawn to the congruent sides of an isosceles triangle are congruent. So this is what we're going to try to prove. So what they give us is that triangle PQR with PQ and RQ congruent. So PQ and RQ are the congruent segments, which means this is going to be an isosceles triangle. It gives us M as the midpoint of PQ, N is the midpoint of RQ. We want to prove that PN is congruent to RM. So the first part, we're going to have 3 questions they want us to answer. So they're going to give us what they want us to do. So the first thing, we're going to do part A. What are the coordinates of M and N? Once again, by the midpoint formula, we're going to find the coordinates of M and N. So let's look for M first. So this one here, we're going to start with our x's, which is negative 2a plus 0 divided by 2. And we get our y values, which will be 0 plus 2b divided by 2. Combine any like terms or get rid of your 0. So we have a negative 2a over 2. And we have 2b over 2. And our 2's will cancel, leaving us with just a negative a and a positive b. So the coordinates of M are negative a, positive b. So let's go to the next part. Look for N. In N, we're going to take our a values, which are our x values, which are 2a plus 0 over 2, and 0 plus 2b over 2. Once again, we're left down to just 2a over 2 and 2b over 2. And then our final coordinate, when we cancel our 2's, becomes just a comma b. So because these have the same y values, we know that these are at the same height. So now we've got our 2 coordinates. So now we've checked off the first part. What are the coordinates of M and N? We found them. Now it says, what is the length of PN and RM? So what are PN and RM? When they give this, guys, this is a segment length. They're asking for a distance, which means you're going to use the distance formula. So for part B, we're going to start by finding the length of PN. Now, what we're trying to prove is that they're the same, so we should come up with the same answer. So let's take a look. We'll start with PN. And once again, we want to start with the furthest to the right, which means we'll start N minus P. So we'll have A minus a negative 2A, quantity squared, plus, since we started with N, we got to start with B minus 0, quantity squared. Now, change our signs here to become plus. A plus 2A is going to give us 3A, quantity squared, plus b minus 0 is just going to give us b squared, all under the radical. Now, because they're 2 separate terms under the radical, we cannot just take out our answers here and have 3a plus b. They have to be combined like they were in the last one under 1 parentheses in order to eliminate it. So the next step is to do square 3a, which means you're going to take 3a times 3a. So kind of over here, I'll scratch it out, 3a to kind of refresher times 3a means it's going to be 9a squared and then b squared. So the square root of 9a squared b squared is the length of PN. So now let's look at the length of RM. So we'll start with 2a minus negative a, all squared, plus 0 minus b, all squared. So once again, we'll change our signs here to make it plus. So we'll add 2a and a gives me a total of 3a, quantity squared, plus negative b, quantity squared. And now we're going to square each term, which means we're going to take and multiply 3a by itself. So it's going to be 9a squared. So you square the 3 and you square the a. And then negative b squared becomes a positive b squared, because the negative times the negative is a positive. So do we show that these are the same? Do they both have the same answer? Yes. So we've done this. We've shown that these two are the same. Now then the last step, it says to explain why PN is congruent to RM. And our reason for this, we can say, is by the distance formula. The distance formula shows that Pn is congruent to Rm. So the distance formula shows that Pn is congruent to Rm. So kind of summarize this. We use the midpoint formula to find our midpoints. We use the distance formula to show that these two lengths were congruent. And then we kind of summed it up by using the distance formula to show that these were congruent. And that concludes our lesson on proving using coordinate geometry.